Welcome to the MOVI-C Cabinet and Decentralized VFDs 201 class. This is Session 2, Cabinet Overview. In this session, we're going to dive into the topic of MOVI-C cabinet products. We're going to look at the different VFDs, their accessories, and their qualities. If you've looked at the length of this video and felt a little alarmed that this is going to be a death by PowerPoint class, don't worry about that. The reason this session is kind of long is because it covers a lot of necessary background content. I like to think of it like those big drinks that you get at a gas station when you're on a long road trip. They seem like a good idea at the time. You get a lot of soda at a really good price, you drink it up, and then a little later you kind of wish you hadn't. Well, this is like a big drink, but hopefully you'll be glad that you drank it when we're done. So stick with it. In our next session, we'll be getting into the hands-on side of things. We'll do our first lab, but this is necessary information, so let's just plunge in and take care of the big drink. We're going to begin by talking about MOVI-C VFDs, variable frequency drives. We're going to give you some background information about them. We're going to survey the ones in the control cabinet branch of the MOVI-C big red umbrella that we talked about last time. And I'm going to begin with one of many important notes that you'll see scattered throughout this class. I want to define some terms that I'll be using a lot. The term axis. The term axis refers to a VFD controlling a motor. So any VFD with an attached motor is an axis. Now be aware that most MOVI-C VFDs are what we call single axis, meaning that they can control just one motor. Now, it is possible to connect two motors in parallel to a single-axis VFD, but those motors are going to run together and they're going to behave basically identically. So that is still a single-axis application even though there's more than one motor. A true multi-axis VFD can control multiple motors independently. And as we'll see, there is one VFD in the MOVI-C control cabinet branch that is true multi-axis. It can control a whole bunch of motors independently. Let's survey the major branches of the control cabinet side of things. There are 6 families within the control cabinet section of the big red umbrella. They become progressively more powerful and sophisticated as you work up to them. I'm going to just survey them very briefly. I'm not going to delve deeply into them. You can see their specifications here, and if you wish to pause the video and look at them more closely, that's fine. MOVITRAC Basic and MOVITRAC Classic are kind of the intro-level VFDs down at the bottom end of the control cabinet branch. They are single-axis. They're generally kind of on the smaller side, so they're meant to run small to maybe medium-sized motors. You can see the maximum horsepower size of MOVITRAC Basic is around 2 horsepower. The maximum size on MOVITRAC Classic is 15. These are what we often call shaft spinning VFDs. They're meant to run those simpler applications where you're just turning a shaft, like fans and pumps. As you work your way up to the next branch, we come to MOVITRAC Advanced, which is actually quite a jump. Notice, first of all, it can handle much bigger motors, up to 420 horsepower approximately. It can control various motor types, and it can do speed and position control. So this is really the first VFD in the MOVI-C control cabinet branch that can handle a wide range of applications. We move on to the MOVIDRIVE technology, and this is really what I consider kind of the sweet spot VFD within the 6 cabinet VFD families. It's an extremely versatile VFD. It's single axis. You can see it goes up to fairly large sizes. It controls many motor types. It has speed and positioning control, and it's got a lot of other powerful features that we'll be talking about. In fact, this is the VFD we're going to focus on in this class. Moving beyond it, we come to MOVIDRIVE system. Now, if you look at this and you look at MOVIDRIVE technology, they look a lot alike, and that's no surprise. They're made from many of the same components. They have a lot of the same features and the same power ratings, but the big difference is that MOVIDRIVE system is typically operated with an SCW Eurodrive controller. And you can see the controller there on the left side. It controls, in this case, 2 VFDs, so a controller can operate multiple VFDs. And as you'll discover as we go further in this class, controllers add a whole new dimension to powerful VFD-based applications. At the pinnacle of the tree is MOVIDRIVE modular. This is the multi-axis VFD that I mentioned. It can control many motors depending how many modules you connect to it. This particular one controls up to 5 motors. It has 3 modules, but 2 of those modules are dual axis modules that can control 2 motors independently. You can see that controller there. This is also a controller-based system. We'll talk about these a little more as we go on. Now in this class, we're focusing on MOVIDRIVE technology because it's kind of in the sweet spot. It's an excellent general purpose VFD that can do both simple and complicated tasks. It comes in a wide range of sizes and it has an excellent feature set, so it's a good focus for this kind of class. Now many of the things you learn about it do apply to the simpler VFDs like MOVITRAC Basic, MOVITRAC Classic, and MOVITRAC Advanced. And most of the things you learn about it also apply to MOVIDRIVE System and MOVIDRIVE Modular. So it's really a good VFD as a learning experience because it gets you up a lot of learning curves, not just for it, but for the products that kind of surround it. We're not going to discuss the low-end VFDs, the MOVITRACs. In this class, I will say a few things about them just so you're knowledgeable, but they're not the focus of this class. We're kind of dealing really with MOVIDRIVE technology. Now I want to talk about a related topic, something called MOVILINK DDI motors. MOVILINK DDI, which stands for Digital Data Interface, is a communications technology that provides a digital data stream between a motor and the VFD over a special hybrid cable. MOVILINK DDI was introduced around the same time as the MOVI-C portfolio. It's a feature that's available in many SEW Eurodrive motors of different kinds, for example, asynchronous motors and servo motors. Its purpose is to create a single cable solution between an SEW motor and an SEW VFD. Single cable solutions are nice because you only have to have one cable linking everything together instead of the usual 2. This is an example of a MOVILINK DDI cable. You can see it's got a lot of wires inside that rather hefty orange jacket. We have wires for the motor, 3 of them specifically, plus ground. There are also 3 lines for the brake if the motor has one, and then there's this little purple coaxial cable with a red connector on the end. That is the digital data stream cable. That connector on there is meant to connect up to a matching one on the VFD. You can see one here on the bottom of the VFD. That's a MOVILINK DDI connector. Many of the MOVI-C VFDs include that, and it carries a lot of information in that digital data stream. For example, it can carry an electronic label that allows the motor to provide its specifications directly to the VFD. It includes encoder data. Encoders are feedback devices that give speed and position information about the motor. If you have a MOVILINK DDI encoder, it will communicate through that data stream too. There's also thermal data if the motor's equipped with temperature sensors that communicate in that way, and possibly other sensors as well, like vibration detectors. All these technologies communicate through that one single little purple cable. It's a very powerful concept, and we strongly recommend that our customers look into our DDI motors because they pair very nicely with MOVI-C VFDs. Now let's pause to talk about another important note here. Most MOVI-C control cabinet products have an IP20 rating. We talked about this in our last session. Remember, IP20 indicates that the device will keep out objects about the size of your fingers and also is not at all liquid resistant. 0 means don't get it wet. They generally have to live inside a control cabinet. That's why we call them control cabinet products. All right, let's take a look at some of those 6 branches of the control cabinet side of things. We're going to start not with the lowest end VFDs because, as I said, we're not really covering them in this class, but we will talk briefly about MOVITRAC Advanced. You can look at the specifications and pause if you have to, and I also call your attention to some of the red terms here. MOVITRAC Advanced is available in 2 voltage ranges, 200 to 240, and it's available in single or 3-phase in that voltage. It's also available in the higher voltage 380 to 500 3-phase only. It comes in multiple sizes and ratings up to 588 amps. Now it's got some important features here that I'm going to call your attention to. It has what's called safe torque off, which in this case is optional on this product. It's a safety feature. It allows you to have a safe torque off e-stop switch, for example. If you hit it, it'll keep the VFD from delivering torque. You can have an optional field bus. That's an industrial communications network that allows VFDs to be connected up to controllers like programmable logic controllers, PLCs. It supports encoders, which, as I said a few slides ago, are feedback devices that provide speed or positioning information, and you can see it has a variety of other features. Now let's move our way up to the MOVIDRIVE technology, which I want to spend more time on since it's the focus of this class. As you can see, it comes in 2 voltage ranges, 3-phase only. It comes in 8 sizes with multiple ratings in each. It includes safe torque off as a standard feature. It includes a field bus card as a standard feature, and there are 4 choices. It has an encoder interface that communicates with multiple encoder standards, very handy. It also includes the MOVILINK DDI interface. It can control a brake on the motor if the motor has one. It accepts keypads. It has 2 expansion slots for adding additional features. And it has a nice amount of digital I/O, input and output. It has 8 digital inputs and 4 digital outputs. It includes a small relay, and it includes a special feature called EtherCAT, which in the SEW world also goes by the name SBus Plus. Let me talk about this in a little more detail before we go any further, because this is an important idea. EtherCAT is a real-time version of the Ethernet networking standard commonly used in offices as well as in industrial automation. The difference between EtherCAT and standard Ethernet is that EtherCAT is real-time. It responds very quickly and in a very predictable amount of time. It's very good for industrial control for this reason. It was developed by Beckhoff Automation, but it's been adopted by many equipment producers. SEW EuroDrive adopted it in its MOVI-C products, and we add our own protocols to it, and so we call it SBus Plus. But when we talk about SBus Plus, you can think EtherCAT. SBus, by the way, stands for System Bus, and you'll find it built in to the MOVIDRIVE technology and a variety of other VFDs. All right, how is MOVIDRIVE technology meant to be used? Well, it can be controlled by a keypad or just on-off switches. But the most exciting way to control it is over a field bus with a programmable logic controller kind of driving the VFD. This gives you the most power and flexibility. Here's a typical installation. You would have multiple VFDs. They're connected to a field bus of some kind, for example, Ethernet IP or Profinet. And then you have a PLC on that field bus issuing commands to the VFDs. This PLC can be one of many different standards out there in the industry. Pick your favorite, and it's almost certain you'll be able to communicate with SEW's VFDs. These are the standards we currently support: EtherCAT, Ethernet IP, Modbus TCP, Profinet and Profibus, as well as Ethernet PowerLink. As you can tell, if you know anything about field buses, these are all the major players currently out there. Let's move on to MOVIDRIVE system. You notice that it has just about the same specifications as MOVIDRIVE technology. It's no coincidence, they're very similar products, but it's got a few differences here, and I want to highlight those, which is why there's a hole here in the slide. Let's fill it in. It has 6 digital inputs and 4 digital outputs, no keypad, no field bus card, and no relay. Now you may be thinking, wait a minute, that seems like you've downgraded the product, not upgraded it. Why is it missing some of those features? Well, part of the reason is because it's usually paired with a controller. It's meant to be used in a system where you have multiple VFDs talking to an SEW controller. The controller provides field bus connectivity. You generally do not use a keypad in those kinds of systems, so this is really aimed at a different set of scenarios than MOVIDRIVE technology. That's why the specifications are slightly different. Now you can run a MOVIDRIVE system in much the same way as a MOVIDRIVE technology. You can run it by switches, or a standalone program running in its controller, or a third-party PLC. This is how things would be set up if you were using a third-party PLC. You would have your VFDs, and you would have the SEW EuroDrive controller connected to them using its EtherCAT SBus Plus network. But then you have your third-party PLC talking to the controller over its field bus. So it's a slightly different architecture, but it gives you a very powerful system, and it adds the advantage with that SCW controller of being able to offload a lot of work from your third-party PLC. These are the standards we support on our controllers: Ethernet IP, Modbus TCP, and Profinet. And then finally, we come to MOVIDRIVE Modular, which is the top of the tree. It has 3 separate components, and it's therefore quite a bit more complex. Let's talk about these. MOVIDRIVE Modular contains a shared power supply module, which powers all the VFDs connected to it, so one power unit for everything. And then it has one or more access modules. Access modules are VFDs that share that common power supply, and you just chain them together. You notice some are wider. That's because they're double access modules that can control 2 motors each. And then finally, of course, you have a controller which provides the intelligence to run everything. MOVIDRIVE Modular is very good for applications that include a lot of axes working together in a coordinated way. This could include something like a robot, for example, or a packaging machine. Now, how do we join all this together? Well, we add bus bars to carry power through everything, and we use S-Bus Plus to link everything together. So kind of like this. And this is our complete MOVIDRIVE Modular setup. Let's look at these individual components now in a little more detail. Power modules operate on 380 to 500 volts 3-phase AC. They come in sizes up to 110 kilowatts, which is pretty hefty. We also make a 24-volt power supply to supply the electronics if you wish to use that rather than your own 24 volts. And even more importantly, we offer a power supply module that handles a very special condition that comes up a lot with VFDs, and we need to go on a quick detour to talk about it. Let's look at a little scenario here where we have a VFD controlling a hoist. Now let's think about what goes on when the hoist operates. When it goes up, the VFD is always delivering power to the hoist, so the VFD is sending energy into the motor, causing the hoist to go up. Okay? No problem there, very standard operation. But when the hoist comes down, something unusual goes on. The motor becomes a generator, and that is because gravity is pulling the load down, and the motor is actually delivering energy back into the VFD, which actually isn't a good thing. The VFD doesn't like that. In fact, it can destroy the VFD if it's not protected against it. Most VFDs contain circuits that shut it down and disconnect it if this should occur. But this still is a problem. And it goes by a name that you probably are familiar with if you know anything about VFDs. We call this regenerative power. It's because the motor is generating energy that goes back into the VFD. Now, regenerative energy doesn't just happen with hoists. It can happen with sloped applications like angled conveyors. It can even happen in purely horizontal applications if you've got a large, massive load. The momentum of that load makes it hard to stop, so when the VFD is slowing it down, regeneration can happen then as well. So it's actually a very common problem in many applications. The question is, what do we do about it? Well, there are a couple things. The simplest solution is to use what's called a brake resistor. A brake resistor is a simple electrical device, and all it does is it takes regenerative energy when it comes back in, and it converts it into heat that it just throws away into the environment. So it's basically a heater that heats up the area surrounding it, and that's the regenerative energy just being wasted. Now, for many applications, this is perfectly acceptable. It's not a problem. It's a quick, easy, time-tried solution. I'll mention as an aside here that most VFDs can work with brake resistors. Now they have to have a capability called 4Q operation. That stands for 4 quadrant, and it means that the VFD has the circuits necessary to cut a brake resistor when regenerative energy occurs. Most of SCW Eurodrive's VFDs include this. Some of the low-end ones do not, or it's an optional feature. Of course, always be sure what your VFD can do before you spec one out for an application. But for example, MOVIDRIVE technology, MOVIDRIVE system, and MOVIDRIVE modular all are 4 quadrant. They can use brake resistors. But there actually is a better solution to dealing with regenerative energy, especially when you have large VFDs where it's a lot of energy and therefore actually valuable monetarily. and that is to use what's called a regenerative power module. Regenerative power modules pair up with capacitors to store the regenerative energy and allow you to reuse it later. So it's a store and reuse approach. And for bigger systems, this can be an economically good idea. MOVIDRIVE Modular supports regenerative power modules. They're an optional feature you can add in if you need them, and we sell the capacitors as well that store the energy. Something to think about. MOVIDRIVE Modular offers access modules in two styles, single and double. A double access module is really just two single access modules in one box. You can see that it has all its features duplicated, so you've got two of everything in there. And as you see, the access modules come in a variety of sizes. A MOVIDRIVE modular can be controlled by switches, but it's more likely to be controlled by either a standalone program that you have written that runs in the SCW controller, or controlled by a third-party PLC. This is how that would be set up. You would have your MOVIDRIVE modular with its controller, everything linked together by EtherCAT and SBus Plus, and your third-party PLC talking to the controller over the field bus. Again, the SCW controller is doing a lot of the heavy lifting, so your third-party PLC doesn't have to devote a lot of time to controlling the application. These are the field bus standards supported by MOVIDRIVE Modular. Again, the three most popular ones in industry: Ethernet IP, Modbus TCP, and Profinet. This is a handy thing that you can do with MOVIDRIVE Modular. Let's say you have an application with a lot of medium and small motors that it handles fine, but you've got one great big motor that's too big for the largest access module to handle. What can you do? Well, it's simple. Get yourself a MOVIDRIVE system, connect its SBus Plus up to the SBus Plus of your MOVIDRIVE Modular, and the MOVIDRIVE system becomes essentially a very big access module. This is a way of expanding the system so it can handle one large access if you need it. One of the nice features that MOVIDRIVE technology, MOVIDRIVE system, and MOVIDRIVE modular have is automatic, easy restoration. MOVIDRIVE technology has a removable memory module. You can see it in the picture on the left. It just pulls out. That module includes all the parameters, commissioning information, and application programs that are running in the VFD, so everything is in there. If your VFD takes a lightning strike and dies, you can remove the memory module, replace the VFD, pop the module into the new VFD, and everything should pick up and run just as it was before. Now with MOVIDRIVE system and MOVIDRIVE modular, there's a slightly different approach. You don't have a memory module in the VFD, but you do have either a removable SD or CFast card in the controller. This card contains the commissioning and parameter information of all the VFDs that the controller is associated with, also any custom programs or any standard application programs. If you have a VFD die, you simply replace it. The controller will detect that the VFD has been replaced and automatically recommission it using the information on the card. So this is a feature that will certainly make maintenance people happy. Let's talk about how the VFDs report their status. Very important if you're doing diagnostics and troubleshooting. Most of the MOVI-C cabinet products report their status through a 2-digit LED display. You can see examples on this MOVIDRIVE modular and the MOVIDRIVE system right next to it. Each unit has a 2-digit LED display that gives key information about its current status. For example, if one of the VFDs happen to be showing C2, that means that it's in safe torque off mode. So it is not going to move because you've triggered the safe torque off circuit to prevent the motor from developing torque. VFD faults are reported a little differently. They begin with the letter E appearing on the display. Then there's a short pause and a number appears, in this case 29. Another short pause and then a second number will appear, in this case 01. That is fault number 29.1. We call the first number the main fault code and the second the subfault code. In this case, fault 29.1 is a limit switch fault. Okay, let's move on and talk about the connectors. I don't want to go into this in great detail or you'd probably fall asleep. I just want to give you a quick tour of the connectors on MOVIDRIVE technology. And I'll point out that MOVIDRIVE technology and MOVIDRIVE system are almost identical in the way their connectors work. There are only a few differences. We'll start on the left side at the top. You can see right there is the keypad and engineering connector. That's the DE9 connector. MOVIDRIVE system is different. There's an RJ10 connector instead, but it serves a similar purpose. It's the engineering connector. The field bus connectors are right next to that. Of course, the MOVIDRIVE system does not include a field bus card. That's another difference. Moving down, you have the I/O connections and the relay connections. MOVIDRIVE system does not have the relay, but it has the I/O connections. And then moving to the center picture, looking at the bottom of the VFD, you see the MOVILINK DDI connector. That's the red one. Right below it is the multi-encoder interface. And then below that are the places you connect up the motor, the brake resistor if you have one, and the motor brake and its temperature sensors if it's so equipped. Finally, moving on to the right, we see the top of the VFD. You have the place where line in power comes in. This is your three-phase AC. Next to it, you have a connection for a 24-volt power supply if you're supplying it externally. Then you have the S-Bus Plus in and out connections. And finally, the connector where Safe Torque Off is connected to the VFD if you have a Safe Torque Off circuit. If you don't, then you normally install a jumper plug, which simply keeps Safe Torque Off from triggering. That's what's equipped here. MOVI-C VFDs have a variety of options and accessories available to support them. We're going to just skim through some of the common ones. We'll start with the controllers. MOVI-C controllers manage MOVI-C VFDs. They work much like PLCs, so you could think of them as small PLCs if you like. They come in several sizes. You see them here. The smallest is on the left. The most powerful is on the right. They're rated by the number of axes they can control, and some of them, the three on the right, can also include Windows as a second operating system in addition to their PLC-like operating system. We're not going to talk about controllers very much in this class because this is not a controller-based VFD class, but I do want you just to be acquainted with some of the key ideas. MOVIDRIVE technology, MOVIDRIVE system, and MOVIDRIVE modular all have expansion card slots that allow you to add extra features simply by inserting a card. You can see three of the common expansion cards here. The CID21A adds extra I/O. The CIO21A adds extra I/O, plus it gives some analog inputs and outputs if you want to use, for example, voltages to control your VFD. And the CES11A is the second encoder card. It adds a second encoder interface should you require one. All the cards on the right are what are called functional safety cards, and the way you can identify these is by the yellow shield symbol on them. Functional safety cards provide a variety of features that are used in certain kinds of safe installations. Notice that every one of them has a removable memory module that allows quick swapping. All the safety commissioning is on the module, so if you have to replace the card, you can swap in the module and the commissioning goes with it. Very handy. MOVI-C VFDs often can work with keypads. We currently offer three different keypads. The CBG11A on the left is a simple monochrome keypad used for just basic tasks. The CBG21A, which is next to it, is a full color keypad. It has far greater capabilities. It's actually very powerful, both as a diagnostic tool and for doing startups. You can also use either keypad as a backup device, and you can use them for manual mode control. The CBG22A on the right side looks like the CBG21A, but it serves a different purpose. It's actually more of a small human-machine interface, HMI. It can also be used on some VFDs for key-activated manual mode control, and you can do basic status and diagnostics with it as well. As a bonus, the keypads all include a mini USB interface that allows them to act as an engineering adapter for MOVIDRIVE technology and all the MOVITRAC VFDs. You just connect a USB mini cable to it, connect the other end to a computer, and you can fire up our engineering software and access the VFD in that way. Again, handy tool. And then finally, we sell a variety of electrical accessories that condition input power and output power, making it more suitable for the application. And we sell a thermal breaker, which protects braking resistors from excess current. So these are really components that solve specific kinds of problems as they're required. And the last thing we're going to talk about as we wrap up this module is documentation. I'm going to point you to 2 manuals that give you all you really need to know about MOVIDRIVE technology, and I've included links in the description below that will allow you to download these from SEWeurodrive.com. And with that, our big drink is finished. You've done a great job sticking with it. Thank you very much. That is the last big drink we'll have for a while. And so with that, we're going to wrap up this module. In our next session, we're going to do our first lab. We're going to become acquainted with MOVI-Suite, our engineering software, and then we'll go into the lab itself. And if you have a demo unit, you'll have the opportunity to do it yourself. If not, you can just follow along with me and I'll walk you through it. See you next time.